Hi, this video here is in continuation of the series of videos that has been done on properties of rational functions. So this is series 2. Now for this video here we are considering case 2, that is the case when the degree of the numerator of a rational function equals the degree of the denominator of a rational function. So in the last video you would recall that we said a rational function is any function that can be written as the ratio of two polynomial functions, that is p of x divided by q of x, provided the denominator does not equal to 0, or else the whole thing here becomes undefined. So we're going to look at a couple of rational functions that want to find the properties. So we're going to find the domain, we'll find the vertical and the horizontal asymptote, or the oblique asymptote, whichever one applies. So the very first example we'll be looking at is going to be h of x equals 3x squared minus 3x divided by x squared plus x minus 12. So like I explained in the previous video, I said before you begin to find the properties of a rational function, that is to find each of all the asymptote, the vertical and the domain of a rational function that has been listed above here, the very first thing you want to do is to factorize both the numerator and the denominator. It is always helpful to factorize that, because before you can find the vertical asymptote, it has to be in lowest term, so it makes your whole work very easy. So the very first step is you want to factorize both the numerator and the denominator. So when you factorize the numerator, so what you'd obtain is 3x into x negative 1. And when you factorize the denominator, what you'd obtain is x negative 3 into x plus 4. So that has been done. So let's go ahead and find the domain. So the domain of the rational function. So we said the domain is the set of all real numbers excluding the numbers, or excluding the zeros of the denominator. That is excluding 3 and x equals negative 4. So all real numbers excluding these numbers here has been excluded there. Why? Because when you substitute 3 and negative 4 into this place here, you'd obtain 0, and it makes the rational function to be undefined. So the next thing is we want to find the vertical asymptote. Now, to find the vertical asymptote, we said the very first step you want to do, as explained in the previous video, is to reduce the rational function in its lowest term. Now the rational function we have is 3x into x negative 1 divided by x negative 3 into x plus 4. So this is what we have. And then when you look at these two rational, when you look at the numerator and the denominator, none of them is common. Nothing is common. So that implies that it's already in its lowest term. So the next step is the zeros of the denominator of the rational function in its reduced form is going to be your vertical asymptote. So since x equals 3 and x equals negative 4, so this is going to be your vertical asymptote. So, and then lastly, to find the horizontal asymptote, so what we said is we want to find the long-term behavior of the function, that is x squared plus x minus 12. So to determine the long-term behavior of this function, all we need to do is approximate the function, that is both the numerator and the denominator, by its leading term. So the leading term is just the term that has the highest degree. You can see the degree here is 2, and the term that has the highest degree, the degree here is 2. So to approximate this, we have 3x squared divided by, when you approximate this, you have x squared. So when this crosses out, so what we obtain is 3. So this is a constant function, so even as x tends to infinity, there is no x here, so it's just still going to be 3. So the horizontal asymptote is y equals 3. And then to see a very little demonstration of all we have said here, so let's see the graph. So looking at the graph, if I want to plot the graph, so let's go straight to, so let me punch my calculator on. So I want to go to the y editor. So my function is 3x squared, so we open brackets, 3x to the power 2 minus 3x minus 3x, so we close bracket, now divided by, so we open brackets, we have x squared, x to the power 2 plus x, negative 12. So yep, so this is our function here. So let's plot it and see what we'll get. So graph, so you can see this is the vertical asymptote. You can see that. So what you'd observe here is the horizontal asymptote is y equals 3. You can see this, while this is the vertical asymptote. To be able to see, to demonstrate, for some reasons, I don't know, for some reasons, probably it's going to be in the settings, y equals 3 is not showing here. But let's go back to the y editor, so we can include y equals 3, so that we would see the way the whole thing is being done. So now we have y2 equals 3, which is the horizontal asymptote, just for demonstration. So now you can see this is the horizontal asymptote. So what you'd observe again here is the vertical asymptote, the graph never crosses. This is the graph here, but this is the horizontal asymptote. You can see the graph never crosses or touches the vertical asymptote, but for the horizontal, the graph crosses it at this point here. You can see that. Alright, so let's see one more example before we call this part quits. Alright, now question example 2, you're going to consider another rational function h of x equals 2x squared negative 5x plus 2 divided by x squared negative 4. Now, like we said, what you want to do is you want to factorize this. So when you factorize the denominator, which is the very first step you want to do, so that's going to be 2x negative 1 into x negative 2, now divided by x negative 2 into x plus 2. So this is what you obtain. So we want to find the domain. We want to find the domain of this function. So the domain is just going to be x, instead of all real numbers excluding, so the zeros of this, that's excluding 2 and excluding negative 2. So that's that. Now to find the vertical asymptote, so we said the very first step is you want to write the rational function in its lowest term. So the rational function we have is 2x negative 1 into x negative 2 divided by x negative 2 into x plus 2. So that's what we have. Now what you'd observe here is this is common, so this crosses out. So what we obtain here is going to be 2x negative 1 divided by x plus 2. So the vertical asymptote is just going to be the zero of the denominator. That is the zeros, just as it sounds, the number that when you substitute it here would make the denominator to be 0, and that is x equals negative 2. So you should note that x equals 2 is not a vertical asymptote. So this is the only vertical asymptote we have here. So again, you'd observe that before I found the vertical asymptote, I ensured that I have written the vertical asymptote, the rational function, in its reduced form. And then lastly, to find the horizontal asymptote, so the rational function that we have, which is 2x squared minus 5x plus 2 divided by x squared minus 4. So we want to find the long-term behavior of the rational function. So the very first thing is we approximate it by its leading term. So this is the leading term and this is the leading term. So that's going to be 2x squared divided by x squared. So this goes off and what we obtain is 2. So y equals 2 is your horizontal asymptote, and then that completes the problem. Thank you for watching.